Hello, everyone. This is the hands-on tutorial section of the Ensure MQTT Security with TLS and EMQX webinar. So in this tutorial, I'll show you how you can generate self-signed certificates and keys, how to examine those certificates and verify the keys using open SSL commands, how you can map those certificates to EMQX for one-way TLS for both on-prem and cloud, then how to test the one-way TLS using OpenSSL commands and MQTTX clients. Then also next we'll add a root CA certificate to the browser and test HTTPS. And then we'll change the brokers to use two-way TLS and then test the two-way TLS connection using MQTTX and HTTPS. And in addition, for detailed instructions, there's a workflow script that will show you detailed instructions for all the steps. So the setup that I have is I'm using a Windows laptop with a Docker Ubuntu image and EMQX Enterprise running inside the Docker image. And also I have MQTTX for testing the clients. And in addition, I have EMQX Cloud Professional plan running on AWS. And I just want to point out that the Docker image plus the EMQX Ubuntu install that I have does not equal the EMQX Docker install that you get if you download the Docker install directly, because that's using an Alpine Linux, which is much smaller. And I just want to point out that you don't have to install EMQX on Dockers for this tutorial. You can install it directly on Linux if you want. So to get a free trial of both on-prem and the cloud versions of EMQX, go to www.emqx.com, and then you can select either cloud or on-premises and follow the instructions from there. And then just to let you know, you don't need a credit card at all. And then to match the setup in this tutorial, you'll want to download Docker's Ubuntu 20.04 image, and then also download and install EMQX for both on-prem, and then you can sign up for a free trial of the cloud version if you don't have it. And then also install EMQTTX for testing the clients. And then you want to you want to download the tutorial scripts that we'll be using to generate the certificates. So here's where you can download the products for free. If you click the try free button, then you can choose between cloud and on premises. So if you select cloud, then you want to make sure that you install the professional plan, because that has support for SSL. And if you select the on-premises, you can choose either EMQX Enterprise or EMQX Broker. And for the tutorial, the one I used was Ubuntu 20.04. But you can basically use any of the Linux installations you want. If you go to our installation page inside our docs, you can see the different steps that you need to do depending on the installation that you choose. So this will give you additional installation steps depending upon which EMQX local edition you choose. If you look at the tutorial.txt file, you'll see detailed instructions for the whole tutorial, but also it includes the installation. So the one thing you want to pay careful attention to is to make sure that you map the ports, if you're using Dockers, from the Docker container to the host. The other thing you may want to do is mount a directory, so it keeps you from manually having to copy files back and forth between the Docker container and the host. So you can just print out the file, or if you prefer, you can use a workflow script that will also print out the instructions. If you type workflow and steps, it'll print out just the steps. If you leave it blank, it will print out the whole file. And if you want instructions for a particular step, just include the number and it'll show you just the instructions for a particular step. Now we'll do step 1, which is to generate the self-signed certificates and keys. So the script that's used is the generate certs script, and that's a high-level script that calls the other scripts to generate the root CA plus 2 intermediate CAs, one for the server, one for the client. And in the demo, in this tutorial, the generate certs is run twice, once to generate local certificates for the local on-prem EMQX, and once to generate certificates for the cloud. And the scripts read from environment variables to set the certificate information. And the certificate files are put into separate directories. One is local and one is cloud. So they're 2 completely independent certificate sets. And the one thing that you make sure that you'll do is make sure that you want to do is to set the environment variables to match your server and client configurations. So here's what the generated certificate files look like. The server.pim file just contains one certificate from the server to the first intermediate certificate. Then the server full chain.pm file contains the complete chain from the server domain to, but not including the root CA. So the root CA is not included. And then corresponding certificates for the clients, it's basically the same. It's the client full chain that has the complete certificate chain up to, but not including the root CA. And then the ca.pim is the contains the root CA. So I'll start by giving you an overview of the different command prompts I have. I have one that's on the host computer that's also a volume that's mapped to a corresponding directory on the Docker's container. So these 2 folders contain the exact same thing, one for the host, one for the Docker's container. And then I have a workflow tab that allows me to print out the different instructions, and that's located in the certs2 directory. And also in the certs2 directory is all the scripts. So you should start off with a directory, it doesn't have to be called certs2, but with all of the scripts. And then I have one tab for the configuration. This is where we'll map the parameters for the EMQX on-prem. And you don't need all of these command prompts. It's just I have it for the tutorial, so it makes it a little bit easier to understand what I'm doing at any one time. And then I don't have to change between directories. So here's the instructions for how to generate the certificates. So the one thing you want to make sure that you do is to edit the environment config file to be correct for your server and client domains, because we'll use that information to generate the certificates. So if we look at that file, you'll see that it has a bunch of environment variables and they're set to a default. So if you want to override the defaults, then make sure that you edit them here and use an export statement to export the environment variables to the correct information that you want. So now the first thing we want to do, if we look at the workflow, is to use those environment variables, and then we'll generate the certificates. So if we go source, so these are set to be for the local on-prem EMQX. Then if we generate the certificates, and if we look at what we have, notice that we have a new directory with a timestamp. So the first thing we want to do is we want to change that to be local. So now we have our local certificates inside the local directory. So the next thing we want to do is change it to cloud. So now we've changed our environment variables to be what we need for the cloud certificates. And if we run the generate certificates again, look at the directory, you can see we have another timestamp directory. So we will change that to be our cloud directory. And we can see that we have certificates for both the local EMQX and the cloud configurations. So now that we have our certificates, the next step is to use OpenSSL to verify and examine the certificates to make sure we understand what they contain. So you can use the following scripts, the show, trace, CA certs, and verify to examine your certificate files. And basically those scripts are just wrappers to OpenSSL commands. So some examples, maybe you want to examine the root CA file to see what it contains. Then you can also check that the root CA is or is not inside the EMQX CA certs file. You can also view the complete certificate files using the trace command. You can view the subject issuer chain. And also if you grep for the grep for the X509 extensions, you can also see the subject extensions that are in the X509 extensions. You can also verify that the dates are valid, for example, and then you can also verify that the public key, private key pairs are valid. So if you look at step 2 in the workflow.sh script, you'll see some examples of what you can do. So for instance, you can use the trace command to examine the subject issuer. You can use the show command to see the entire certificate. So if we look at some examples, maybe we can check for the validity dates. So basically we just grep for validity. We can also show the X509 extension. So this is important because you may have subject alternate names that won't show up in the trace command. So another useful script is trace, because then if we do that to the server full chain, you can see the all the subject and issuers for all of the scripts, all of the certificates in the file. So you can verify what your certificate files contain. So we can see that the server file only has one certificate. And if we want to look at the root, then we can verify what it contains. And if we want to verify the keys, we can use the verify command to verify that our server key pair are valid. Now that we know what the certificate files contain, our next step is to map them to EMQX parameters. So for on-prem, we will map them in the listeners.config file, and we'll use the server.key and map that to the key file parameter, and server full chain will map to the cert file. So we'll do that in 3 different sections, in the SSL, WSS, and for HTTPS, we'll use the EMQX dashboard config file and map the same files in that file. So note that the only files we really need is the server.key and the server.fullchain files. And then to specify that we want one-way TLS, we'll set the verify parameter to be verify none. And I just want to point out that in this tutorial, I will stop and start the broker, but it will update automatically in a few minutes. So that's really an unnecessary step. It's just so that I can save time during the tutorial. So that was how to map EMQX on-prem. And for EMQX Cloud, you want to go to the overview page. And for one-way TLS, you want to specify one way. And then you'll use the server.pem file and map that to the certificate body, and the server full chain.pem file and map that to the certificate chain. And then the server.key file will be mapped to the certificate private key. And it takes a couple of minutes for this to set up. And then you'll know it's ready when it says running. And also you can verify that all the listeners are listening to the SSL ports too. So now to configure the parameters for EMQX on-prem, we want to go to the EMQX, etc. directory and open the listeners.config file. The easiest way is if you search for key file, then you can see that in the SSL configurations, I have the key file mapped to the server.key in the search2 local directory. And the search file parameter is mapped to the server-full chain, also inside the local directory. So make sure you use the local directory and not the cloud. And for one-way TLS, we don't need to map the CA cert file. That's only used for two-way, so it's commented out. And if we go down to verify, we can see that it's set for verify none to verify none. So that means we'll be using one-way TLS. And then this doesn't really matter, but I have it set to false. And these are the SSL configurations. So if we look for key file again, you'll see the corresponding secure WebSocket, WSS configurations. And again, the key file is mapped to the server.key. And the cert file parameter is mapped to server full chain, just the same as before. So this is exactly the same. And then the CA cert file is not used. And if we skip down, we can also see that set to verify none and false. So this is how you configure the parameters for local. So now just to keep things simple and to make it go faster, we can stop and restart the broker. So again, it will update automatically. So this is really unnecessary, but just to make it a little bit faster for the tutorial. So now the local broker is started automatically, restarted. So for EMQX Cloud, because I'm using Dockers, there's one step I have to make. I have to transfer the files, the certificate files from the Docker image to the host. So I now will copy them to my mapped file, which is this certs host. So if we can now see that they are copied to the mapped folder. And also if I do this, we can see now the certificate files are copied to the host. So now I can map them to the cloud, EMQX Cloud. So here I am in the cloud console. So if you go to the overview page, you'll see that I don't have any TLS SSL configurations. And if you look at the connected ports, it's only listening to the plain text ports. So I need to add the certificates. So I select one way. I could choose one way or two ways. So I'll start with one way. And for the certificate body, I want to make sure I'm in the cloud directory and select server.pem. And then for the certificate chain, I want the server full chain. And again, making sure I'm in the cloud directory. And finally, the private key. So that's the server.key. So then if you press confirm, you'll see that the state is pending. So it will take about a minute or so to change to running. So when it changes to running, then it's configured properly. So after a few minutes, you'll notice that the state is now set to running. And now we have 2 additional ports that EMQX Cloud is listing on, our 2 TLS ports that we just added. So now, now EMQX Cloud is configured properly. So one correction on the local EMQX configuration, you'll want to also configure HTTPS. So that's located in the plugins directory in the EMQX dashboard. So if we open up that file, you'll see the exact same parameters, key file, and that gets mapped to the server.key, and cert file that gets mapped to the server full chain. And same as before, the CA cert file is commented out because it's not needed for one-way TLS. And you'll see the same verify is set to verify none, and this is set to false. So again, you'll need to configure the EMQX dashboard in the plugins directory also. So now that we have mapped our certificates to both the brokers, now we can test them using OpenSSL S client. So these scripts basically are just wrapper scripts that wrap the S client and all of its associated options. So there's 3 scripts, one for SSL, one for WSS, and one for HTTPS. And basically they're the same, it's just they're connecting to different ports. So if you run them in the local directory, you can test the local broker. And if you run them in the cloud directory with the cloud option, you can test the cloud broker. So here we are in the local directory, so we can test the SSL connection. And so it returns a lot of verbose information that you can look at. And you can also grep for certain errors if you want. So I'm going to wait for it to end. And then if you go scroll up to the top, you'll see this is the actual S client command that was sent to the localhost port 8883. And you can see all of this nice information. So it prints out all the information for everything for every step of the TLS handshake. But more importantly, it also verifies that the correct certificate files are actually on the broker. So you should see this match what you're expecting. If it's not, it means maybe there was a typo when you configured the certification mappings. So basically, it just lets you know that everything is correct. So you should see the correct certificate chain. And so these are the actual certificates that the broker is using. So there's one for WSS and also one for HTTPS. So you can check the local, and if you also want to check the cloud broker, you can do the same thing, but you need to specify the cloud option so it picks the right certificate files. So now you can verify that the certificates are correct on the running brokers. So now that we've tested one-way TLS using S client, we can now test with MQTTX. So in this tutorial, you'll create 4 different clients for the local and for the cloud brokers. So remember, they're actually separate brokers, so they won't be connected to each other. But in each of the clients, we'll be using its own connection. So you'll have one example of every type of connection that you can have. So just a couple of things to watch out for is that make sure that the host address has the correct broker, either the on-prem broker or the cloud broker. So that has to be the correct address. And it defaults to a public broker.emqx.io, which is a valid broker. So it could be that your client connects, but you don't see it listed on one of the brokers. And that could be because it's actually connected to the public broker. So here's some of the settings that you want to watch out for. And that is for SSL clients, you want to set the SSL parameter to true, and then self-sign, because we're going to be using self-signed certificates. And then pay attention to the CA file and make sure that you're using the correct folder location. And then for the non-SSL clients, you'll want to set SSL to false. So those will be plain text clients. And then here's an example of connecting to the local broker. In my case, the address is localhost. Then you want to use the CA PIM file inside the local directory. For MQTTX Cloud, you want to use the cloud host name. Plus, for cloud, you want to make sure that the username password is correct, and that needs to be set inside the authentication section of EMQX Cloud, or else the client won't be able to connect. And also make sure that you use the cloud folder for the CA file. Then what we'll do in the tutorial is we'll have each client subscribe to the same topic, test topic, which is the default topic when you subscribe. Then we'll verify that the clients are listed in the respective brokers. And then finally, we'll publish a message and verify that all the clients were able to receive the message. And because the brokers aren't connected, it'll be just the clients in the respective brokers. So here we are inside MQTTX, and we have 4 clients connected to the local broker and 4 clients connected to the cloud broker. So if we look at one of them, this is the SSL client for the local broker. Notice it has the local broker address, SSL to true, self-signed certificate, and more importantly, it's using the local CA file for the local broker. So if we click connect, it will connect. And if we look at the corresponding cloud client and its parameters, it has a host address for the cloud, SSL true, self-signed, and using the ca.pim file inside the cloud folder. So it connects. So now we can go verify the brokers on the respective brokers. But first, notice that they're all subscribing to the test topic. And if you hit new subscription, the default is test topic, and hit confirm for each client, and they'll all subscribe. But notice I've already that they're already subscribing. So the next thing we'll do is we'll verify that the clients are on the respective brokers. So if I look at the cloud broker in the client in the monitor page, I can see all 4 cloud clients are connected. And if I scroll down, I can see that they're all subscribing to the test topic. And if I go to the corresponding local broker, I can see that the 4 local clients are connected. And if I look at the subscriptions, they're all connected. They're all subscribing to the test topic. So back in MQTTX, if I put a valid JSON message inside the payload section and press the green button here, then I will publish the message to all of the brokers, all of the clients in the local connected to the local broker. And you can see that they all have received the message. And if I choose a client in the cloud section and press publish, then I can see that all the cloud clients have received the message. So the one that's selected, you won't see a 1 because it displays the message directly. But then if I click on the different clients, I can see the published message. So now to test HTTPS, we'll have to add the server root certificate to our browser, because if we tried to go browse to localhost 18084 using HTTPS, it would complain about not having a valid certificate. So basically, for Chrome and Edge, the process is about the same. Eventually, you'll come down to on Windows to the Windows certificate dialog box, and then you want to add the ca.pim file to the list of trusted CAs, and then we can test using HTTPS. So if we try to browse to localhost 18084, we see that our browser complains that there's not a valid certificate. So if we check out the certificate, we'll see that it only has a certificate to my intermediate CA, and then the browser complains that it could not find the root CA. So that's why we have to have the root CA added to our browser. To add their certificate in Chrome, we select the three dots, settings, and type certificate, security. If we scroll down, we'll see manage certificates. Then regardless of which browser you use, you should come to this screen, this dialog box. So we click the trusted root certificate, and you just want to verify that if you're rerunning this tutorial, that the old certificate, my root, is not in there, which it's not. So we select import, we get a wizard, we browse to our local certificate, and you may have to change this to all files. And we're looking for the ca.pim file in the local directory. And then click next, next, everything's okay. So we get a verification, we're going to add it, say okay, and we should verify that it is indeed added. So we should see our my root CA as part of our trusted root certificate authority. So then we reset the browser. So I switched over to the Edge browser, and notice that now if I browse to localhost 18084, so the certificates are now valid. So if I look at the certificate path, I can see that there's a valid path from the localhost, an intermediate CA, to the my root CA. Just one note, I can't restart the browser because I'm using it for this video. But if you check yours, if you restart the browser, you should see that it comes up and says connection is secure. So in your tutorial, it would be shown okay. So next, we'll change the brokers to use two-way TLS. So for EMQX on-prem, that means changing the verify none to verify peer in all the three sections. And for EMQX Cloud, that means just selecting two-way instead of one-way. To set up EMQX Cloud for two-way TLS, we will first delete the existing one-way TLS setup that we have. Click OK. And then we add TLS, but this time we'll choose two-way. And these files are exactly the same. The certificate body, which is in the cloud directory certificate PIM. So these haven't changed from before. It's the server full chain and the server private key. And in addition, since we're using two-way TLS, we'll need to add the client CA certificate. And in this case, it's shared by both the client and the server. So it's the ca.pim inside the cloud directory, and then say confirm. And then like before, it will take a couple minutes to set up, and then we should see it change to the running state. So after a few minutes, you'll see that now the two-way TLS is set to running, and you'll see all the different listeners listening to the different ports. So now for the local broker, we want to edit the listeners.config file. And again, search for key file. And this time what we want to do is we want to add the CA cert file, since it's two-way TLS. So we'll use the CA PIM for that. And the other thing we need to do is we need to change the verify to verify peer, and also this to be true. So it's the same for the corresponding secure WebSocket. So again, we enable the CA search file and set the verify to verify peer and this to be equal to true. So it's the same for the dashboard configuration. We go to the plugins directory. And we want to edit the EMQX dashboard file. And you'll find it's the same. We want to enable the CA search file and set it to ca.pim, and also verify peer instead of verify none, and set this equal to true. So now that we've configured the brokers to use two-way TLS, we can test them using MQTTX. Basically, it's the same as before with just a couple of additions. If you want to clear the history and see everything from scratch, you can clear history. And the other thing you'll want to do is you'll want to disconnect all clients and reconnect them. So basically, the one difference we need to do, because we're using two-way TLS, is we have to add the client certificate files when we connect. So you'll have to do that for all the all the clients that are using SSL, and just make sure that you're using the right CA file for the local versus the cloud broker. And then for the browser, we need to add the certificate in the personal certificate section. The one thing, at least on Windows, is it may complain about a .pm file format. So you have to convert it to a PXF format using this syntax. And then you can connect the browser using two-way TLS. Then after you configure the local broker, you'll need to stop and restart it. So now in MQTTX, you'll want to disconnect all the clients using this icon here. So at least disconnect the TLS clients. And notice that with the TLS clients, if we try to reconnect, they don't connect because they're not the broker set for two-way TLS. And the reason it's not connecting is because we haven't entered the client files here. So we'll need to do that for all of the TLS clients. And if you want to start from scratch and not see the previous messages, you can click clear history. So now I've edited the client configuration so that they contain the right file. So down here in client certificate, I've added the client full chain. And again, be careful of the directory. Make sure that the local one is in the local directory. And I've added the client key file. So now it's able to connect. Same here. And again, for cloud, you add the client full chain in the cloud directory and the client key also in the client in the cloud directory. So it will be able to connect. So you can verify in the brokers that all clients are connected. But then, like before, if we publish, we should see that all clients receive the message in the local directory. And if we publish cloud, we can see that the corresponding clients in the cloud directory. So now we've demonstrated that the clients can connect using two-way TLS. The last thing we want to do is to add the client certificate to our browser personal certificates, but at least in Windows, it needs to be in a PXF format. So a little bookkeeping that we'll have to do is to convert it to a PXF format. So you see that little script just converted it to a PXF format. So now we can add it to the trusted certificates. So just like before, we need to add the certificate to the personal certificate store. So in Chrome, settings, security, and manage certificates. The only difference is now, instead of adding it to the trusted root certificate, we're going to add it to the personal certificate. So we say import, next, browse, and you may have to change the filter. And in the local directory, we're looking for the client full chain, and it has to be in a PFX format because it contains multiple certificates. So that's the reason. So if it was just one certificate, it wouldn't have to be in this PFX format, but otherwise it does. So we hit next, it asks for a password. So we'll just hit blank. We want to put it in the personal store, hit finish. And now we can see that it was added. So now we can go test our two-way TLS connection in the browser. So now when we try to browse to our local host using HTTPS 18084, it'll ask us to choose our client certificate. So we choose the one that we added, say okay, and now we can log in. So now we successfully logged into the dashboard using two-way TLS. So that's it for the tutorial, and I hope you've enjoyed it.